Hello, good day viewers. In this tutorial, we are going to learn how to solve second order linear non-homogeneous differential equation using Laplace transform. The question we have for today is y double prime minus 4y prime plus 4y equals e to the 2x x to the power of 3. We are given some initial conditions here. Y of 0 equal to 0, y prime of 0 is also equal to 0. So what we need to do here is to take the Laplace transform of each term here. We have 1, 2, 3, and 4. All right. I don't have much space, so let me just go direct. The Laplace transform of y double prime will be equal to s squared multiplied by the Laplace transform of y minus the power of s will reduce by 1, so we have s multiplied by y of 0. The power will reduce by 1 as well. We have just y prime of 0. We are done for y double prime. Then we move on to the second term here. Let us factor out negative 4. Then we take the Laplace transform of y prime. All right, we have factored out negative 4. The Laplace transform of y prime will be s, because the order is 1, multiplied by the Laplace transform of y. Then you subtract. The power of s will reduce by 1. We just have y of 0. Moving on, we have 4 outside, multiplied by the Laplace transform of y. And to the right hand side, we have the Laplace transform of e to the 2x, then multiplied by x to the power of 3. Okay, let me remind you of something. Remember, if we have the Laplace transform of e to the at multiplied by t to the power of n, this is equal to n factorial divided by s minus a, which is the coefficient of t here, raised to the power of n plus 1. But remember, our function is in terms of x, so we can just replace this and this by x. So this becomes ax, and this becomes x to the power of n. So let us relate this and this so that we can get our Laplace transform. Therefore, the Laplace transform of e to the 2x, where our a here is 2 and our n here is equal to 3, we have 3 factorial, which is the same thing as 3 multiplied by 2 multiplied by 1, which is the same thing as 6. So we have 6 here, divided by s minus a. We have s minus 2 because a is equal to 2 here, raised to the power of n plus 1. Our n is 3 plus 1 equal to 4. So we have 4 here. This is still useful. Let's continue. But we can just substitute our initial conditions here. You can see y of 0 is equal to 0. Y prime of 0 is also equal to 0. So let me mark them. We have this equal to 0. We have also this equal to 0. We have this equal to 0. I want to neglect them. So the only terms we have is this. Then we distribute this negative 4 over here, and this one and the last one. Here we have s power 2 Laplace transform of y. This is 0, this is 0. Then minus 4 times this, we have minus 4s multiplied by the Laplace transform of y. This is 0. Then we have plus 4 multiplied by the Laplace transform of y. And to the right hand side, we have 6 divided by s minus 2 to the power of 4. Okay, now let us factor out Laplace transform of y. we have s power 2 minus 4s, then plus 4. All of this multiplied by the Laplace transform of y. And to the right hand side, we have 6 divided by s minus 2 to the power of 4. We are moving. This is a perfect square quadratic trinomial, which is the same thing as s minus 2 to the power of 2. Remember, half of 4 negative is negative 2, squared is 4. This means that this is a perfect squared. Multiply by the Laplace transform of y, and this is equal to 6 divided by s minus 2 to the power of 4. Let us bring Laplace transform to the left and take what I mean here. Let us divide both sides by s minus 2 to the power of 2. Already this is s minus 2 to the power of 4. If you divide, it will multiply the denominator. We have powers 2 plus 4 equal to 6. Therefore, to the left hand side, we have the Laplace transform of y equals 6 divided by s minus 2 to the power of 6, because 2 plus 4 is equal to 6. What do we do next? We can take the inverse Laplace transform of both sides in order to obtain the value of y, because inverse Laplace will cancel this Laplace. So to the left hand side, we have just y, which is a function of x, and this is equal to the inverse Laplace of this. We can factor out 6 to the top, so we have 6. The inverse Laplace transform of 1 divided by s minus 2 to the power of 6. All right, how can we find the inverse Laplace of this? Remember, if Laplace transform of this is equal to that, if you take the inverse Laplace of both sides, taking the inverse Laplace of this will give us back this function right here, which is a function of x. Let's do that here. If we have something in this form, we have n factorial divided by s minus a raised to the power of n plus 1. So we can relate this power of 6 with n plus 1, which is the same thing as 5 plus 1. So we can write this one as, let me even make it big, 1 divided by s minus 2 to the power of 5 plus 1. All right, but having 5 plus 1 here, remember 5 is our n, we have to have 5 factorial to the top. So we can just say that y of x equals 6 multiplied by the inverse Laplace transform of 5 factorial divided by s minus 2 to the power of 5 plus 1. By introducing 5 factorial here, we can just divide it here to negotiate or to compensate. This multiplied by this, we get 1 back. Okay, now we are free to relate this with that. So from here, our final answer will become, but 5 factorial, remember it is the same thing as 5 multiplied by 4, which is 20, multiplied by 3, which is 60, multiplied by 2, which is 120, multiplied by 1 is still 120, but 6 can go into 120 20 times, so we have 1 over 20 here. We have 1 over 20, so y of x is equal to 1 divided by 20, then multiply by, all right, let us relate this and this. We have e to the ax, e to the ax, but what is that a? A is this 2, so we have 2x. Multiply by x, to which power? To the power of n. But n here is this one, which is equal to 5 here. So power of 5. And hence, this is the solution to this differential equation right here. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.